Hi guys, welcome to more ASL Maths Mechanics exam questions. This time we are doing kinematics. More specifically, we are looking at variable acceleration. So these are the questions where you're given expressions in terms of t for either displacement, velocity or acceleration. Let's go. First up, I've made this page especially for these questions. Displacement, velocity and acceleration are linked. Velocity is the rate of change of displacement over time, and acceleration is the rate of change of velocity. So, to get from displacement to velocity, differentiate. To get from velocity to acceleration, differentiate. To get from acceleration to velocity, integrate. To get from velocity to displacement, integrate. And I've also chucked in the Suvet page because we have a tiny bit of this to do too. So download the questions, you get these two pages too. Alright, let's go. Okay then, first up, a remote-controlled toy car is moving over a horizontal surface. It moves in a straight line through point A. The toy car is initially at the point with displacement 3 meters from the point A. Its velocity, v meters per second, after t seconds is modelled by v equals 0.06 times 2 add t minus t squared. Part A wants us to find an expression for the displacement r meters of the toy from point A at time t seconds. Okay, so here we're using r for displacement. Sometimes it's r, sometimes it's s. Make up your minds. Alright, so we know that displacement is the integral of velocity. So r of t is the integral of velocity. So we're going to expand this. So we're going to have 0.12 add 0.06 t minus 0.06 t squared. With respect to t. Now, if we integrate that, we get 0.12 t add 0.03 t squared minus 0.02 t cubed. And then of course it's an indefinite integral, so plus c. Okay, now we need to find c. How do we do that? We need to know something about a displacement at a certain time. We know at time t equals 0, we were told initially the toy is 3 meters from A. So that tells us when t is 0, r is 3. Now that tells us that c is 3. All of the t terms disappear. So, finally, r of t is 0.12t add 0.03t squared minus 0.02t cubed plus 3. Done. Given for part B, the bit of Suvet, so we're using G as 9.8 meters per second squared. So at time t equals 2 seconds, the car launches a ball which travels directly upwards with initial speed 3.43 meters per second. We want to find the time taken by the ball to reach its maximum height. Okay, so we don't care about the car now at all. So, do we know displacement of the ball? No. We know its initial speed. So, u is 3.43. Now we also know the final velocity we are interested in. At its highest point, it's stopped going up and is about to start going down. So its final velocity is 0. Acceleration is acting down, so minus 9.8. And we want t. So the one we're going to use is v equals u add a t. So from that we get 0 is 3.43 minus 9.8 t. From that we can add 9.8 t, divide by 9.8, and we will get t is 0.35 seconds. Key number 2. A car, starting from rest, is driven along a horizontal track. The velocity of the car, v meters per second, at time t, is modelled by v equals 0.48 t squared minus 0.024 t cubed, for t between 0 and 15. Part A wants us to find the distance the car travels in the first 10 seconds. So we want the displacement from its initial starting point after 10 seconds. So we need to integrate to get displacement. So S is the integral of 0.48 t squared minus 0.024 t cubed. with respect to t. Okay, so this is going to give us S is 0.16 t cubed minus 0.006 t to the power 4 plus c. Now, we know we're interested in displacement from a starting point. So, when t was 0, we know displacement was 0. So that tells us c is 0. So, displacement is just 0.16 t cubed minus 0.006 t to the power 4. Now we want that when t is 10. So t is 10. Gives us S as 160 minus 60, which is 100 meters. Okay, now part B wants us to find the maximum speed of the car. So the maximum speed of the car happens when you've sped up as much as you can and then you can't anymore. So you are no longer accelerating. So we need acceleration equal to 0. So we should start by saying for let's call it V max A is equal to 0. So what we're going to do, find acceleration, the expression for it, set that equal to 0, solve for t, substitute that into our velocity. So acceleration is the derivative of velocity so that gives us 0.96 t minus 0.072 t squared. Okay, now we're going to set that equal to 0. Now I'm also going to factorize it, so we can say t times 0.96 minus 0.072 t is equal to 0. Now this then tells us either t is equal to 0, but that was just the car being at rest. So the one that we are interested in is t is equal to 0.96 divided by 0.072. Now, to 3 sig figs, that gives us 13.3 seconds. Okay, so we now know the time of the maximum speed. So what we do now is substitute t equals 13.3 into v. So for that you should get 28.4 meters per second. And part C wants us to deduce the range of values of t for which the car is modelled as decelerating. Okay, so the model itself is only for t greater than or equal to 0, less than or equal to 15 seconds. We've just found that the car accelerates up to its maximum speed, which it achieves at 13.3 seconds. Now, because that's a stationary point, instantly after, it's then going to decelerate. So we know that we are decelerating for t greater than 13.3 seconds. Now, the model is only valid up to t equals 15 seconds. So the upper bound is t less than or equal to 15. Okay then, final question for this set, probably the nicest of them. So a particle of mass 400 grams is initially at rest at point O. The particle begins to move in a straight line so that its velocity, v meters per second, at time t seconds, is given by v equals 6t squared minus 12t cubed. Part A wants us to find an expression in terms of t for the force acting on the particle. Okay, so force is mass times acceleration. Now, be very careful, mass is always in kilograms, so 400 grams is 0.4 kilograms. So we have 0.4 A. Now we know that A is the derivative of velocity, so A is going to be 12t minus 36t squared. So force is 0.4 times that, which is 4.8t minus 14.4 t squared. Okay, then part B wants us to find the time the particle next passes through O. So, for the particle to pass through O, we want displacement to be 0. So, we want S to equal 0. Now, we know that S is the integral of velocity. So, S is the integral of 6t squared minus 12t cubed dt. So that is going to give us 2t cubed minus 3t to the 4 plus c. Now, we know when t was 0, displacement was 0 because the particle started at O. So, when t was 0, S was 0. So that tells us C is 0. Okay, now remember that we want S to equal 0. So now we set 2t cubed minus 3t to the 4 equal to 0 and solve this for t. So there's a common factor of t cubed. So it's t cubed times 2 minus 3t. Now the t cubed tells us t is 0, but we knew that. So what we're interested in is 2 minus 3t is equal to 0. So that tells us t is 2/3. And that's seconds. Boom. Okay then guys, that's the end of this set. Really hope it's helped. I have enough questions to make another one, so that'll be the next video in the playlist. Remember to put any requests for topics you want done in the comments down below. For now, take it easy, take care.